Let's move on. Section 2. Wind Turbine Generator System. Some of you may know that a wind turbine generator system provides several merits. It is clean and it doesn't need fuel cost. From 2009 to 2011, I and my research team from the Indonesian Institute of Sciences, in collaboration with researchers from the Ministry of Energy and Mineral Resources, conducted joint research and development of a wind turbine generator system. The usual requirement is that the system has power capacity of 100 kilowatt with wind cut-in speed of 2.5 meter per second and rated speed of 12 meter per second. The average wind speed is 7 meter per second. From computer-aided design, the turbine rotor diameter becomes 24 meter, and the height of the hub at the top of the tower is 35 meter. We use a three-phase generator. The turbine and the generator are coupled by a gearbox. Now, let's make a comparison between our system with the one in Sidrap, Sulawesi Island. Our system capacity is 100 kilowatt with rotor diameter of 24 meter. The one in Sulawesi has the capacity of 2,500 kilowatt. So, how much is the rotor diameter? Yes, by assuming the same average wind speed, we get the answer. The capacity is proportional with square of diameter. It should be 24 meter multiplied by 5. It is around 120 meter. This gives us understanding that capacity is only a matter of size. Because both turbine types are the same, our knowledge and experiences of designing this wind turbine generator system, I think, can be used to build a similar 2,500 kilowatt system. Next, I found that there are at least 3 challenges to build a wind turbine generator system. These are wind speed variation, corrosion potential due to seawater, and specific location, which may be quite far from consumers. My research team duty is to find a method which maximizes power conversion. I remember at the time publication was still limited. Let's pay attention to this relationship between power of wind turbine and wind speed. Our method relies on this power versus wind speed curve. Here we see that there exists a maximum power point for every wind speed. Therefore, the principle is to control rotational speed of the turbine. By doing so, we can keep it at the maximum power point. Next, we use a double-stage power converter. The generator converter converts the 3 phases AC voltage from the generator into DC voltage in the DC link, whereas the grid inverter converts the DC voltage into AC voltage in the grid and load. Here in this photo, we can see there are 2 power converters, each with a gate unit and a controller. At the right hand side, it is for the generator converter. At the left hand side, it is for the grid inverter. Notice that we also have some relays for protection, inductors, transformer, and a PLC for monitoring. These results show that our electric power control method works well. Next, why do we need a yoke mechanism control? Because wind direction varies. It is necessary to face the turbine to the incoming wind direction. We developed an active yaw control system using electric motor with a gearbox, a pinion, and a sliding bearing. These experimental results indicate that our air control system functions well. To ensure safety, we developed a mechanical brake control system using a brake disc, a hydraulic pack, sensors, and an electronic controller. These results demonstrate that the brake control system works satisfactorily. Finally, let's assess its capacity factor. This is probably a real contribution of my leading thought. It seems it has been kept in secret. Frankly speaking, the wind turbine generator system has small CV value. It is only around 23%. In spite of this, why do we invest? Now, it is clear that there is a trade-off between CV value and free cost of wind. Therefore, we have to carry out detailed feasibility study prior to investment. Ladies and gentlemen, let me take a minute to convey my acknowledgement. The results related to wind turbine generator system that I have mentioned before are credit to my team members. In this opportunity, I would like to deliver my gratitude to Mr. Adit Sukmanugraha and Mr. Anwar Mukarrabin. Please stand up, my fellow team. And ladies and gentlemen, let's give a big applause to them. Thank you.